Why don't we take just a couple of minutes to make sure that you and I have a baseline understanding of what a relational database is, or what at least I mean and what most people mean when they talk about a relational database. It can be a little bit confusing because it's one of those words, it's one of those phrases that's tossed around a lot by experienced database administrators and database programmers. Relational database, oftentimes known as an RDBMS, which stands for Relational Database Management System. Interchangeable terms, I just simply use the term relational database. And if you don't know what it is, or if you're brand new to databases, it can be a little bit confusing. So let's break it down. We'll talk first about the database portion of the relational database phrase. A database, and you might know this already, this is a bit more of a common phrase or has a bit more, a bit more widely used vernacular, but a database you can think of as a permanent store for data that exists beyond the lifetime of a session, application, or power cycle. So a database is a place to permanently store your data. And when I say beyond the lifetime of a session, what I mean is imagine you are sitting down for your workday and you key some information about a sales order into an application, and then you close that window or you move on to a new sales order. You get up and you go to lunch and come back later. Well, you start a new session, but you want that data that you already keyed in to remain. If you were to go look it up tomorrow or later in the day or next week, you still want that data to be there and to be visible. So it has been stored beyond the lifetime of your session. It's also been stored beyond the lifetime of the application. A lot of data in a programmed application exists in memory, and when you shut down that application, that data evaporates essentially. It's gone. It is not remembered. But a database is a way to store it even after you shut down the application, beyond the lifetime of the application. So if you shut down the application, you go home for the day, you come in the next day and start the application back up, that data is still there. It's also intended to be stored beyond a power cycle, and I mean that exactly what it sounds like. If you reset your computer, or if the server where the database is stored is shut down and started up later, the data was written to fixed storage on the hard drive, so the data still exists. It persists beyond the lifetime of even a power cycle. That is the idea behind a database, and that is what a database is intended to do. It's also intended to do this in a way that we can easily and efficiently store that data, retrieve that data, search it, analyze it, aggregate it, and do a lot of other things. But at its heart, at its core, what a database is meant to do is permanently store your data. Now, the relational part is a little more complicated, and that's where actually the trickiness comes in. A relational database, and this is just sort of a loose colloquial definition, is the data stored in a structured format with recorded relationships between the elements or entities. That's a little more difficult to explain or understand, but the idea here is that your data is stored in a highly structured format and it relates to one another. So imagine if you had a bunch of Word documents, 1,000 Word documents with a bunch of sales orders typed into them, just saved in a folder on your hard drive. Well, that wouldn't be very useful. How would you, for instance, look up the average price of the sales order or the total for a given month? It's all in a bunch of text documents. You couldn't do that. Conversely, imagine if that data was all typed into a bunch of Excel worksheets or a bunch of spreadsheet worksheets. Now you could easily summarize a column or group together that data. You could imagine you could write functions in Microsoft Excel in order to get that data out, and that is what you should think of a relational database as being. In fact, I use that analogy a lot. A relational database is a lot like a spreadsheet. Data is stored in individual little cells, and the cells relate to one another. All of the data that is in column B is the same type of data. Maybe it's someone's last name, maybe it's the sale price, maybe it's the quantity ordered. And all of the data that is in row X, row 5 or row 7 or whatever, relates to each other as well. That's all the data that relates to a given sales order, for example. So a spreadsheet is actually a very good example of a relational database. And I would encourage you to keep that in mind if you are new to databases as a way to sort of understand how a database is structured. Now, relational databases are not the only type of databases, and when we use the phrase relational databases, we're actually talking about pretty specific type of databases. You're likely familiar with some of these or the names of some of these. These are databases like MySQL, SQL Server, Postgres, and the one that we are going to talk about inside of this Nugget series, Oracle database. These are commonly used relational databases, and they share a few features or traits that make them reasonable to group together as alternatives or stand-ins or competitors for one another. For one, they use SQL to interact. We'll talk a lot about SQL over the coming weeks here inside of these nuggets. SQL is a standardized language for interacting with databases, and all of these databases listed here, and most relational databases, it's sort of implied or assumed that SQL is the language you are going to use to interact with them. They are also, like I said before, they're highly structured. These are incredibly well-structured, formed databases. Data's got to conform to the structure when it is saved in a database. They have fixed schemas. We'll talk about what schemas are in another nugget, but they don't change very much. They're fixed and set in stone. And they have these things known as foreign key relationships, which allows you to, again, relate data to one another. So data over here that is orders might have a key, a foreign key for customers, and that relates back to the customer data, so you know which customer is related to that order inside of that database. That's an example of a foreign key relationship. And this is used in comparison with a brand of popular databases that are today called NoSQL databases. There are a lot of NoSQL database options out there, things like Mongo and Cassandra. They're very, very popular. NoSQL databases may or may not use SQL. Contrary to the name NoSQL, NoSQL actually stands for not only SQL. So they may use SQL, they may not. They're very loosely structured. They have mutable schemas, so you can change and update the schema as you go. And there's often very few relationships between the data. The reason you would use non-relational databases, NoSQL databases, is essentially a trade-off for speed. Usually they take up more space or they are less efficient for writes, but they allow you to read data much more quickly. And the only real takeaway there is that NoSQL databases are not better or worse than relational databases. These are two sides of a similar coin, and they both are better in different use cases, so you should make sure that you're always using the right one. Now, of course, this Nugget series is focused on Oracle DB, which is a relational database, and that is the type of interaction and the type of database that we are going to be learning about. So that covers what is a relational database. I hope you have a better understanding of A, what a database is, and B, what makes it relational. I hope this has been informative for you, and I'd like to thank you for viewing.